Good afternoon, everyone. Hello, my name is Karan. I'm in the Surface engineering team.
My name is Daniel Garrity. I'm with the Microsoft Endpoint Management team.
And we are here today to talk about Surface UEFI settings and the ability to manage them from Microsoft Endpoint Manager. So quick show of hands. How many of you went to the hands-on lab that Daniel and Sean did yesterday at 4 p.m.? OK, good. So you know what we're talking about. And for the rest of you, there's a redo of that session again tomorrow, also at 4 p.m.?
Yes.
I would highly recommend going there. You'll be able to actually kick the tires with this technology in that hands-on lab. If you're on the wait list, do not hesitate to go. Yesterday, there were a few no-shows, so there were some empty spots there. That's what we're talking about today. So the picture you see over there, that's the Surface UEFI settings. Everyone, I assume, in this audience knows what these settings are. For different devices, there's a different procedure or a different incantation for entering these settings. On all of the Surface devices, there's a consistent, if you hold down the volume up button when you're powering on the device, that's how you get there. And what we're talking about today is the ability to manage them at scale remotely from Microsoft Endpoint Manager. And what these settings let you do, these are kind of low-level settings that let you manage system and firmware and hardware settings. This could be things like what devices you want to be able to boot off of, so whether you want boot from USB, boot from, or Pixie boot enabled, or things of that nature. And in our case also, we have the ability to enable or disable different pieces of hardware. So if you have privacy concerns and you want the camera to be disabled on your devices, that's something you can go in there and actually disable. There's a few different interesting properties of the UEFI system that are actually both beneficial from a management perspective, but also pose some challenges. So what are those, right? So the biggest one, perhaps, is that if you think about the UEFI, it's like a Russian doll, right? It's a system within a system. We generally think of the PC as the operating system and the apps on top of it. Well, actually, there's in the pre-boot environment, there's a UEFI that actually comes up for a brief moment during boot, and then it kind of goes away. And that property, the fact that it's a separate system that comes up during boot, poses its own challenges, which are actually beneficial in some cases, right? So the challenges are that because of that limited system, it doesn't have the same notion of authentication and Windows authorization that you've come to expect in Windows. So that means if you're going to manage a device, you need to figure out who the authorized owner of the device is, because this concept of who is the local admin on the box makes no sense to the system firmware. But some of the benefits are that the settings that are managed in the UEFI or anything in the firmware layer is actually persistent across OS reinstall. So if a malicious user gets hold of your device and wipes the OS clean, well, any settings that you managed at the firmware layer are resilient to those type of attacks. Same with the local admin, right? The local admin has inherently no permissions over the firmware settings. So those are some of the benefits. But again, the challenge is that it's a system within a system that knows nothing about your local Windows user account passwords, or knows nothing even about AAD, Active Directory, or anything of that nature. So we'll talk as we go deeper and deeper. We'll talk about how we solved for some of these challenges. Now, why would you want to manage? I mean, it should be based on the previous slide. You should have already kind of, you know why. But to go over it again, it lets you control you want to be able to sometimes control the access that the local user has over the firmware settings. So again, thinking back about the kind of things that you can do from the firmware settings, you can wipe and reload the OS. Well, if you don't want the local user or the person who has the device in their hand to be able to do that, this is how you would do it, right? Typically, in the past, you would have gone in and kind of set a BIOS password on all of your devices, and that's a very manual process where you need to walk up to each device and do it individually. And then again, reiterating, there's interesting device there's interesting settings there around managing device settings. So whether you want the camera to be enabled or not, and things of that nature. And just to kind of go full circle, if you if you remember back the picture that we had on 2 slides before, this is the managed version of that settings UI, right? So here again, we are trying to mirror what the settings page in Windows looks like, and what it's trying to tell you here is, these settings are managed by your system administrator, and that's why they're kind of grayed out. Again, mirroring how this works in Windows. Before we drill deeper into DFCI, let's just do a quick overview of like how would you go do it today, right? So again, quick show of hands, who's familiar with that screenshot? Okay, good. So that's a screenshot just for the rest of the audience. That's actually a screenshot coming from the Surface UEFI itself. So this is not Windows UI, this is Surface UEFI UX. And this is how we enable firmware management today, right? Before DFCI, if you want to do Surface UEFI management, you have to go deploy a permissions packet on all of your devices. And the problem with the current solution, not to kind of shoot my own, the predecessor of this technology too much, is that again, because of this lack of, we don't have a notion of who owns the device. We use this UI as a way to kind of confirm that the person who has the device physically in their hand, that person agrees with whoever the IT person pushed down that settings packet. They both agree. So what it is asking you is, can you please type the last 2 digits of your thumbprint? And this isn't knowledge that you would have, the user would have a priori. The idea is that the system admin would tell them, hey, this is when you get prompted for these 2 digits, please go enter this. And this is a way for us to, again, confirm that the person who has the device in their hand right now agrees with the management policy that is being laid down on the device. But the problem with this is, it should be clear, is that now, before you, for the enrollment process to complete, you actually need to walk physically to each device and hack this screen, right? And if you haven't done that, then your management actions are not going to apply. So that's our current solution, and we kind of designed it to be secure. But in order to make it secure, we kind of had to make it cumbersome because again, we lacked the foundational technology that we're building DFCI on. So that's option 1. And on a lot of devices, actually, there's an option 2, which is there's a very easy option, but it tends to be very insecure. So a lot of devices, you can get a simple exe or something that you download from the OEM, and whoever happens to run the exe for the first time takes over control over your UEFI settings, and from that point on, you're good to go. But again, that's simple, but that's not secure, because what that means is now anyone who happens to come, you're open to drive-by attacks, right? Anyone who happens to run this exe before you got to run it can take over control over your system firmware settings. With that said, today we are announcing DFCI, which is somewhat of a mouthful for device firmware configuration interface, and we are bringing these firmware settings to Intune, and this is available as of last week in public preview in all of your Intune portals. So when you go back, you should see the DFCI profile type, and we'll walk you through what that looks like. You should see the DFCI profile type, and you should be able to start playing around with this technology. Along with that, we're also very excited to kind of lead the industry in this space. Kind of very early on, we realized it's one thing for us to do this on Surface devices, but really from you guys' point of view, from our customers' point of view, it's no good if you do it one way on Surface devices, and another way on some other OEM's devices, and a third way on another OEM's devices. So we made the decision to basically include all of the foundational DFCI technology in something called Project Mu. Project Mu is the Surface UEFI that we ship on our devices, and it's the open source project for that. So you can go to that link, aka.ms/DFCI. You can see our source code there, and that's actually available for our OEM partners to pick up and adopt. And that piece is the foundational kind of technology that enables settings management. So as I said, very happy to kind of lead the industry in this space. Now let's start drilling down into what DFCI is, how it works, and so forth, right? So as we were thinking about building this out, we had some, few design pillars in mind. The first of them, going back to this notion of the 2-digit PIN that I showed earlier, that was key, right? This had to be in line with the modern management principles, and we had to make sure that the experience was completely seamless from an IT and a user experience point of view. So or to put it differently, we wanted a completely zero-touch experience for deployment and enrollment. No passwords. Again, historically, when you've done this, you've had to think of passwords and either individualize them for each device or have a single password that is shared across all devices and hence insecure. DFCI is built using public key cryptography, so it's secured using certificates, which means you don't have to worry about securing passwords and so forth. And then again, along this notion of security, there is a set of decisions we made around defense in depth, meaning the device had to be always recoverable, even if things go wrong. We'll show later on what that actually translates to in terms of the implementation. And essentially, what it basically means is DFCI plugs into this, the modern Windows provisioning model, or Autopilot, right? So Autopilot is the key foundational piece that enables us to do the zero-touch experience. Because if you think about it, besides the fact that Autopilot lets you automate all of your out-of-box experience, the other thing, the service side for Autopilot gives us is this notion of who is the authorized owner of this device. So as part of the DFCI workflow, at one point we reach out to the Autopilot service and go, is this tenant the authorized owner of the device? And if that tenant is the authorized owner of the device, then we let them manage the PC. And that's how we know when we apply those settings on the device, we know they're coming from an authorized place, and we can apply them without having to do this challenge response of 2-digit PIN and so forth.
All right. So now to get into some of the technical details, what does it actually look like to set up DFCI in your own environment? So Curran went over what it looks like on the device and how you manage it today. So on the left, you can see this is the local view of device settings. And with DFCI and the zero-touch deployment system with Autopilot, we have now brought those to be a new profile within the Microsoft Endpoint Management Console as part of Intune. So it's just another profile, another device config that you can go set, deploy out to Azure AD security groups, and it will go down and be applied to the device. But for those who aren't familiar with Microsoft Endpoint Manager or the Intune component of Microsoft Endpoint Manager, I want to walk you through the outline of how this process is built up and all the prerequisite steps you need to actually get this environment going. So as Curran mentioned, the foundation for especially these low-level settings, because they're so secure and because they persist on the device in a very permanent sort of way, the foundation is we must have an authorization on the device's own identity, as well as Intune's normal authorization on the user who's enrolling the device. So in order to fulfill these two foundational pieces, let's talk about authorizing the device. How many folks in the room are using Autopilot or are familiar with Windows Autopilot today? Outstanding. So as you may know, in order to use Autopilot, you first have to put the device's identity into your Intune environment through a registration process. And there's multiple registration processes, whether you are uploading hashes you extract locally from the device and you can upload those directly through the Intune console, you're using admin.microsoft.com, or you're using Microsoft Store for Business. Those are all driven by you as the customer who just has local access to the device. However, the only option that DFCI will honor for registration is if the device has been registered to Autopilot by a Microsoft Cloud Solution Provider partner. This is a deliberate security decision that we made as part of the design of DFCI because we do not want anyone to be able to just randomly take a hash off device and then hijack the firmware. We actually need an external third party attesting to the chain of custody of who actually purchased the device. So if you have a CSP partner, they can register the devices on your behalf to Windows Autopilot. If you're working directly with an OEM, and the OEM is directly registering the devices to Autopilot on your behalf, that will also be honored.
Yeah, and for Surface, we don't have an option that is available at scale for the OEM registrations, but you can go talk to your Surface seller, buy a few devices from the retail store, and they can help you register for the purposes of a proof of concept or so forth. So that's not if you think about at-scale deployments, that's not a at-scale solution, which is why we haven't mentioned it there. But if you're thinking of doing just a proof of concept and you want to try it on a handful of devices, go talk to your Surface seller, and they can help you through that process.
So definitely, if you're going to roll this out at scale, make sure you're working with a Microsoft Cloud Solution Provider. The second part is the authorization of the user. Now, for those who are already familiar with how Autopilot is set up, there's several one-time setup configurations that you have to do in Azure Active Directory. Microsoft Endpoint Manager leverages Azure Active Directory as its source of truth for user identities. And as part of that, Autopilot requires that you have to go to Azure Active Directory and set permissions to allow users to join devices to Azure AD. This is the equivalent of domain join, but for the cloud. The users also have a setting known as MDM scope. MDM stands for Mobile Device Management. Autopilot leverages the Mobile Device Management agent on Windows 10 to actually do the Autopilot enrollment. And you'd want to collect the Autopilot devices that your CSP has added to your Azure AD environment into a single group, because all the rest of the management is about assigning these profiles and settings to Azure AD security groups. Once you have those one-time tasks set up, the actual management of the device and the device settings are operations within Intune. So again, these are just the normal prerequisites for Windows Autopilot. You have to make sure you have an Autopilot profile assigned to the group of devices. Optionally, you can also set up the enrollment status page, which it gives you more detail on the progress of the Autopilot provisioning, and then deploy the all-new device firmware configuration interface profile to your designated group. This technology also works as a cloud attached value if you're using System Center Configuration Manager. So as was announced earlier this week, with the rebranding of Intune and System Center Configuration Manager together under the new one product brand of Microsoft Endpoint Manager, this is a reason why you might be interested in looking into co-managing your PCs with Intune. So if you already have SCCM set up, DFCI will work. If you are deploying with Autopilot and then you're bootstrapping the SCCM agent later for co-management, you can continue to leave the device configurations workload in SCCM and then manage the DFCI settings in the Cloud Console at devicemanagement.microsoft.com. So let's actually look at what an actual device running DFCI looks like, and we're going to live show you changing the firmware settings from the cloud over the internet. So here we are on a Surface device, and we've already provisioned it with DFCI, and if you look for a camera, we've disabled it at the firmware level, which means it's literally gone as far as Windows is concerned. You can't run diagnostics, you can't triage it in any way.
Yeah, so if you were doing it outside of the firmware settings, a lot of times there's OS options available for disabling hardware. It's just important to point out that we are managing these settings at a lower level than the operating system. So from the OS point of view, there is no camera at this point. I mean, you can look in this device manager view, there is no camera. You open the camera app, it just doesn't have one right now. And now what Daniel's going to show is the portal side of DFCI and actually show how we can go about enabling this camera if you wanted to do so.
So here I am in the Microsoft Endpoint Manager console at devicemanagement.microsoft.com. And if I go to Devices, this is our new refreshed portal schema where we cleaned up the left nav, and now you can just immediately go to Devices and you'll see all the different resources you can assign to different devices. I'm going to take advantage of our brand new platform pivots, which filters everything to Windows. You can see we have this one enrolled device. I'm going to go down to our configuration profiles, and I have this DFCI configuration policy. So I open that up, and under settings, you can see here are all the various settings that you can actually set. Now, the very first setting is unique in that it's not actually a feature per se of the UEFI. It really is more of a permissions setting to let you, as the IT administrator, decide how much control do you want to leave the local user. Once the device is enrolled and activated in DFCI, nothing changes to the end user. It's just enrolled. When you come to this policy, you can choose what should the end user be allowed to do. By default, it would say only not configured settings, meaning if you, the IT administrator, do not specify any particular value, then the setting remains open for a local user or a user who knows the BIOS password to go in and change at will. If you set a value, say cameras have to be disabled, then that immediately becomes grayed out and the end user is not allowed to change it. Or you could choose none. And the interesting thing about this value is that not only are settings you don't leave any value, if you're happy with the settings that the OEM ships with by default, or there's more settings that Intune has yet to actually expose here, but you've worked it out with your vendors, they should be configured this way, and you just want to freeze it out and you don't want the end user messing with them, you can just set this to none. And even though we only have a handful of settings exposed in the first release, this none option actually grays out all of the device settings in the UEFI menu, even if they're not actually shown in this console. So it just grays everything out. The few settings that we did decide to ship in the V1 around being able to force enable CPU and I/O virtualization, a few settings around common hardware groups, and the idea of this V1 is this should be broadly applicable as more OEM partners and other device vendors pick up support. This will be just a common baseline standard for DFCI. So a device may have 3 or 4 different cameras, but we decided to start with just a few easy groups of if you just want all the cameras off, you can just turn all the cameras off. Same with the audio devices, microphone and speakers, and the radios. The one thing to be careful about disabling all the radios is if the device doesn't have a hardwire internet connection, once you've disabled this, this is like cutting off the branch you're sitting on. Intune will no longer be able to communicate with it, so be careful whenever you're using that setting. And then to finish it off, we have a few boot options. One boot option is to block from external media. So this means any sort of external storage that can be attached to the device to stop users from booting Linux or booting another version of Windows, or booting from network adapters is the final setting. So as you can see, we've disabled the camera here, so I'm going to go ahead and re-enable the camera. I have to actually set it to be enabled again. If I just set it to not configured just means we're not sending any command, and per the setting above, it may become unlocked for the user to begin turning on and off at will. But if I just deleted this policy, or I just set everything back to not configured, all the menus will become unlocked once this is processed, but whatever values I had last set will remain set. So if I just set this to not configured, the camera will still be off. The user would have to go back to the UEFI menu to turn it back on. So I'm actually going to set it to enabled. So when this policy processes, it actually turns the camera back on. So I now save the policy. And now Intune will be processing this policy change. And for Windows 10 devices, they will automatically sync on a regular 8-hour basis, or any time the user boots and logs in the device that's been longer than 8 hours. But for the purposes of this demo, we'll just go ahead and force a manual sync, which you can do through the Windows Settings app. As you can see here, this is the Azure AD user account that shows this device is managed by the Contoso Corporation. Typically, syncs, when they are successful, will take 2 to 3 minutes to complete. During this time, the device is checking into the Intune service and asking, I have all these different settings and applications. Do you have anything new for me to come down? Now, you can do it manually from the device, but you can also do it directly from the console. So if we switch back to the console really quick, I can show you. The other way we can do this is if I, as the help desk or the IT administrator, I can actually open up the device and request a sync directly from the cloud console.
Okay, so the sync is done. That was well played, Daniel. I'm going to now restart. These are for UEFI settings, so to actually make the setting apply on the device, you do have to restart the device. I'm going to do that right now.
So at this point, the device will have received the settings to Windows, because Intune, as an MDM management solution, is talking to the inbuilt MDM client on the device. And so that is now said, oh, you have updates, here's your new settings. So the settings are now sitting in Windows. Windows now needs to pass those settings down to the firmware, and the firmware will only check for settings when it is running, which is during the boot process, which is why we're actually rebooting the device.
It's going to come up, just because we are applying those settings, it adds just a small amount of time to the boot process, boot time. So typically, maybe a second or so it adds to the boot time just to apply those settings. And that's just if there is a settings application happening during that boot. If there is nothing to be applied, then the boot time is unaffected. Type my password right, and now if I open the camera application,
It didn't pick it up.
Okay, let's come back to this. Let's do another sync here, and we'll come back to this. Let's continue the demo for the presentation for the moment.
So while we're waiting for that to process, typical policy changes from Intune can take up to 10 minutes to process, and with the conference Wi-Fi, that may be a bit throttled at this point. So while we're waiting for that to process, let's go back to the console, and I'll show you the actual setup of the Autopilot configuration that I'm actually using to provision this. So if we go back to the devices view and go back under Windows, all of your Autopilot configurations are under the Windows enrollment menu. There's a section dedicated to Windows Autopilot, and under devices, this is the first place that you'll see the registrations come. Oh.
This guy.
Yeah. Thanks. So going back under the Windows section, under Windows Enrollment, all of your Autopilot information will be down in this section under the Windows Autopilot Deployment Program. Under the Devices list, this is the very first place that you'll see registrations from your cloud solution partner appear. As soon as they've registered it on your behalf, you can go ahead and sync with the Windows Autopilot service, and the registrations will appear. And initially, they'll have a profile status of not assigned. And that's because you, as the customer, haven't defined how you want the device to enroll to your organization. Windows Autopilot has multiple scenarios for different types of devices. Laptops used by information workers, digital signs or kiosks that don't require any user account. And to customize that experience, you actually have to create an Windows Autopilot profile. And like any profile, that is assigned to groups of devices. So the very first thing that you'll likely want to do is create a group for all your Autopilot devices. This is just a normal Azure Active Directory security group. And here I just have an assigned membership group. And when the device first comes into Azure Active Directory, it will just have its name equal to its serial number. The device hasn't actually talked to any of the cloud services yet. It's just been registered for Autopilot by your cloud solution partner. But since this device is actually enrolled, it actually has a name. Once you have your devices into a group, then you can actually go and create the Windows Autopilot profile.
We can move back.
So under deployment profiles, here I can actually create the profile itself. Just give it a name. And here's all the settings that Autopilot allows you to configure. User-driven is where we actually authenticate with a user account, the enrollment, and that's what we're using today. DFCI actually supports all of the autopilot scenarios as far as user-driven, white glove, or self-deploying mode. The typical settings you have in Autopilot allow you to hide various pages of the Windows setup process. You can skip the privacy screen, skip licensing terms. You can hide the change account option, which on the very first screen in Autopilot where you have to authenticate, there's usually a link at the bottom that says domain join instead, which is kind of an escape route where the user could go set up a local account on Windows. The Autopilot allows you to just hide that link so they can't click on it and bail out. You can also decide whether or not the user is a local administrator or a standard user on Windows. This is also where you'd be able to enable white glove. And if you want, you can use the exact same name template scheme that Windows Configuration Designer, if you're familiar with provisioning packages for Windows, allows you to automatically rename the device as part of the Autopilot process. And then assignments is the standard way that we actually make this effective. Everything within Microsoft Endpoint Manager on the Intune side where you're creating profiles or settings and resources, they don't actually take any effect until you assign it to a group. And that group will be the group of Autopilot devices we defined earlier.
Switch back.
All right.
Yeah, so it was working. For some reason, I had to log off and log back on for the camera app to pick it up. But you can see again, the camera is available in the device manager, and at this point, even in the camera app. Every other time we've tried it, it shows up in the camera app just fine. This time I had to do another restart to actually have it show up here. But in any case, that's what that process looks like.
And so this means you can actually reach down from the cloud to manipulate any sort of firmware BIOS setting without having to physically touch the device, without having to share the UEFI passwords.
And just to point out a couple of things, this is stuff that we can't actually project on the screen, so these are screenshots. There's a new tab, if you're familiar with the Surface UEFI settings, there's a new tab that shows up when your firmware is capable of doing DFCI. That's the management tab that you can see over there. And the two screenshots, the one on the above, the first one on the top, that's what the device looks like. That's what that UI looks like when you get a fresh device from the factory, right? So the thumbprint at on the first screenshot there, that's the thumbprint that's installed from the factory during manufacturing time to enable the zero-touch management. And then the bottom one actually shows you the same UI once the device is enrolled and being managed by an Intune tenant. The other thing I want to point out is the opt-out button. For some reason, there's valid reasons why if you don't want your devices to have the ability to be zero-touch managed by Intune, you can, when you get the devices from the factory, you can hit the opt-out button, and that's a revolving door, so you can change your mind anytime you want. Opt out initially. If you change your mind later on and you want to actually manage some settings, then you can go back in and opt in again.
So to dive a little bit deeper into the life cycle, the device will have to autopilot provision in order to activate DFCI. And during autopilot, which we didn't walk you through, it will actually trigger a reboot. This is similar to reboots, other sorts of reboots that can happen during autopilot provisioning for Windows updates, changing from Pro to Enterprise SKUs, manipulating S mode. Once that reboot happens, that's what actually enrolls the firmware to DFCI and enables management. For your first round of settings to apply, the device will need to check into Intune, and this will likely happen during the rest of the autopilot provisioning process. And that's when Windows first receives your first DFCI settings. You'll need a second reboot to actually enforce those settings. We're looking into how to automate this in a more streamlined process, but in the first version, you're actually going to need 2 reboots to go from nothing on the device to fully locked down UEFI settings. From that point, the device will enter its steady state during its management lifecycle where the settings are enforced. Anytime you want to change or update the settings, it'll have to go through the same process. It will have to have at least synced successfully once with Intune, and then it will need to be rebooted. Either locally, as we did here, or again, you can go to the Cloud Console and you can actually initiate reboots through Microsoft Endpoint Manager. Now, when you're done with a device and you actually want to take it out, there's two important steps to consider when it's managed with DFCI. The first is just plain retirement. As I mentioned earlier, you're going to want to make sure whatever the device leaves management, whatever state you want it to be in, make sure you've set a DFCI policy in that state. Typically, that would mean going through and creating a exit policy that has everything enabled, or whatever you want it to be. Because again, if you just retire it, hit the retire button in Intune and wipe it out, DFCI will remain in force. All of the menus will remain locked. So if you care about having those menus unlocked, make sure you apply a policy that enables everything or sets everything to not configured is the recommended approach, so that they're unlocked when it leaves management. But if you forget to do that, there is a method to recover the device. Devices will remain enrolled to your organization even if you unlock the menus, and that's where recovery comes in. If you're interested in actually giving the device away to another organization and they want to take advantage of DFCI, you'll want to actually do the recovery step. So a complete end of life cycle, and you want to have everything cleaned off of the device. You want to go in, set a policy with everything to not configured, make sure that is enforced and applied. Then you can retire the device from Intune. Now the device will stay, the UEFI will stay enrolled to your organization even after you've retired it from Intune. The key to removing it from your organization is to remove the Autopilot registration record. You can delete it directly from the Intune console after it's been retired from Intune. And then if you want to completely wipe out the enrollment on UEFI, you want to launch the UEFI menu, and under Manage, it'll still say it's managed. All the menus will be unlocked, but it will still say it's managed by Contoso or whatever. You go to the Management tab, and under Configure, you'll have this Refresh from Network button. You click that, and that will contact Autopilot and say, am I still owned by a company? Does Contoso still own me? And Autopilot will say, nope, you're no longer owned by anyone because you deleted the Autopilot registration, and that will authorize UEFI to become unlocked. At that point, the device is entirely back to its original state.
And you do need, for that to work, you do need a wired Ethernet plugged in, so either a dock or a dongle to be plugged in.
And it needs to be a Surface authentic
That's right.
Wired Ethernet adapter.
So to start summarizing and putting everything together again, what are the, just to reiterate kind of some of the requirements that we have for DFCI, and we'll talk about the availability there as well. But the first one, the big one, is that the firmware on the device has to be capable of doing DFCI. Secondly, the OS, there's a small piece in the OS that actually knows how to apply the firmware settings that are coming down, and that also confusingly called the CSP, is available in 1809 version of the OS. So as long as you're deploying 1809 or newer, you're good to go from that point of view. And then thirdly, the devices do have to be registered for Autopilot by a CSP. Sorry for the confusion. Sorry for the reuse of acronyms there. And then finally, the devices themselves have to be Autopilot provisioned. From a device availability point of view, we announced the 3 new products on October 2nd. All 3 of those devices ship from the factory with firmware capable of doing DFCI. They don't all necessarily support the same level of functionality from a management, what you can manage on those devices. The biggest one being that the Pro X does not have the ability to disable hardware components, but you can still manage the ability to boot from USB and boot from Pixie Boot and the security settings there. So summary, some of the key benefits that DFCI provides. It provides a seamless zero-touch experience, both from an IT perspective as well as a completely seamless or a non-intrusive experience for the end user. There is no deployment of on-premises infrastructure required. Again, thinking back to how we do this today with SEMM, you have to provision your own PKI, you have to install a tool on a desktop somewhere, to build these config packets and so on and so forth. There is none of that required here. You just log into the Intune console and off you go. The DFCI is also tightly integrated with the management, with the Microsoft Endpoint Manager. Again, that's not the case with either SEM or any of the other solutions out there. There's no agent required on the device. Like, it's just seamless management, just like you would expect to manage any OS setting, in fact. And then finally, the solution is co-management ready, so you don't have to, the solution can meet you where you are today. Of course, if you're cloud first and doing all of your management through Intune, it works in that case. But if you're an SCCM shop and you want to do firmware management, you can do that using co-management. That's it for our session. That's a list of all of the Microsoft Surface sessions at Ignite. The one I would like to remind you again of is actually the last one on the list there. That's the hands-on lab that Daniel and Sean are doing. Go attend that. Again, if you're on the wait list, do still go there. There were a few no-shows yesterday. That's where you'll be able to kick the tires with this and try this out for yourself.
Yeah, there we'll actually be handing you each your own Surface device that you'll actually get to do the work on yourself and see it work as you are making it happen. Question?
And submit your evaluations, please.
Do you know how far away it is before the other OEMs are going to be on board with the DFCI?
We don't have any ETAs yet, but we are actively working with them. All right, thank you very much.
Thank you.